Welcome to another fun online lesson where we're going to look at finding the volume of a cylinder. So before we start thinking about the volume of a cylinder, we need to think back and consider the volume of a rectangle. Now, we know that all rectangles have two bases and that the bases are parallel to each other, and because they are parallel to each other and the sides are all formed by congruent rectangles, we know that we have uniform bases. So the bases are uniform in prisms. And because the bases are uniform, that means we're also going to have uniform cross sections. So any cross section of a figure where the bases are uniform is going to have uniform cross sections. And because we have uniform bases causing uniform cross sections, the volume formula is volume is equal to the area of the base times the height. So let's take a moment and consider a cylinder. So if we just sketch a cylinder here, we've got a circular base, the curved surface, and our other circular base. We can just take a moment and note that we have our bases, and we notice that these bases again are parallel. So we have uniform bases. And if we have uniform bases, that means our cross sections are going to be also uniform. So we have uniform bases and uniform cross sections. Now let's just stop and think for a moment. When we looked at the prism, we knew that because we had uniform bases and uniform cross sections, that our formula was volume equal to area of the base times area of the height. Now, when we look at our next picture with our cylinder, we notice that with cylinders, we have uniform bases as well. So uniform bases meaning we have uniform cross sections, so we can make the assumption that the volume formula is volume is equal to the area of the base times the area of the height. So it is the same formula for a cylinder as it is for a prism. So as we continue on with that, we want to think, well, what's the formula for the area of the base if the base is a circle? Well, hopefully we recall that that would be pi times the radius squared for the area of a circle, and then we want to multiply that by the height of the prism. So the volume formula being volume times the area of the base times the height. So let's consider what this means in solving a problem. So first we have our method 1. So we can just label that method 1, and then maybe we want to highlight that a little bit so it stands out in our notes. Do something to make special attention noticeable to it. So we have method 1, and in method 1 we want to solve the following problem. We want to find the volume of a given cylinder when we know that that cylinder has a height of 5 inches and a radius, or rather a diameter, of 3 inches. So what do we want to do? Well, we have to first find the radius, and we know that our radius is equal to our diameter divided by 2. So if we take our diameter, which is 3, and we divide it by 2, we now have our radius. So our radius is 1.5 inches. Now we want to use that in our volume formula. So let's go ahead and go to the volume formula. So we know our radius is 1.5, and we know our volume formula is volume is equal to the area of the base, which is pi r squared, times the height. So as we look at this, we know that we're going to substitute in 3.14 for our pi, and for our radius, we have 1.5 squared, which is 1.5 times 1.5 times the height of our figure, and the height of our figure in this instance is 5. So as we start to do our math, we start to we multiply those figures together, and we get 35 and 325 thousandths. When we round that as directed to the nearest tenth, 35.3 cubic inches. Now I can look at this same kind of a volume problem from a slightly different angle. I can look at that and kind of think of this as method 2. In this instance, I want to find the height of my cylinder when I already know the volume. So again, I want to think about my formula, and my formula is that the volume is equal to the area of the base times the height. And I know that that means I have the area of the base is pi r squared times the height. So I'm going to use substitution at this point so that I can fill in the things that I know. I know that I'm using 3.14 for pi, and that my radius is given as 1.4, and I'm going to be squaring that. So it means I need to do that times 2. Made a small mistake there. 1.4 times 1.4. And then I'm looking for what is the height. I don't know, so the height is still h. The volume I'm given as 36.9, so I can fill that in for V. And as I continue on through my problem, I have 36.9 equal to, and when I multiply all of those, you can pause the video and then multiply them and then restart it when you're ready. So I'm multiplying, and I find that I have 6.1544H. And the next thing to do when I'm balancing this equation is I'm going to need to divide both sides by the coefficient of H, which is 6.1544. And I'm doing the same thing on the opposite side to maintain equality. Make a note for myself that I divide at this point. And then I find my final value for H. So you can restart the video. And then my directions tell, after I find that H is equal to 5.995, and the decimal continues on, but I only need to round it to the nearest tenth. So in rounding that to the nearest tenth, I see that I would round up, and I get 6.0, which means that my final answer is 6.0 inches for the height of my figure. And again, remember my last step was to round. So first I substituted the values that I needed, then I multiplied, then I divided by the coefficient, and then I rounded to the nearest tenth to find my final solution of 6 inches.